Welcome everyone. Welcome to another webinar hosted by Chemical Engineering Life. And thank you so very much, Mr. Saud, for being with us here today. It truly is a pleasure. Mr. Saud, he himself is a chemical engineer, graduate from the University of Gujrat, and also a very, very seasoned and a very professional chemical engineer that has multiple years of experience from the field, and is also now the founder of his own consultancy firm. I will leave the introduction to Saud later to himself. But
Yeah,
coming back to, sorry, but you can actually introduce yourself now. So go ahead.
yeah. Okay, that's the brief introduction about me. I'm Mohammed Saud Khalid, and I have some sort of the process field experience of fertilizer and sulfuric acid production of about three in products. And after that, I've started my own consultancy firm. So here you can see that there is the name of my consultancy firm, which we are dealing in sulfuric acid and SSP plants in Pakistan. We're providing the consultancy firms to different manufacturers and suppliers of sulfuric acid and SSP or SOP fertilizer. Instant. After my graduation, I have done about 2 or 3 jobs in my industrial career. So after that time, I joined some projects and I've completed the installation of sulfuric acid plants in Pakistan. Now I'm working as a project consultant with Preventive acid fertilizer company in Pakistan, which is about to install a 50 metric ton per day sulfuric acid production line near Islamabad. And after that, there is a chemical industry which are my clients in Multan that are SCI Private Limited, and then there are one of the key clients of my industrial consultancy. Those are ACI Chemicals, which are located in Shehudpura. And it is an honor for me to be part of that global community. And Chem Engineering is doing great work for the services chemical engineer and to share the knowledge, to expand their learning and experiences, and to discuss the ideas within the global society of chemical engineers. Now, let's begin. What are the core agenda and what are the key topics of today's discussion? So, there are the contents of our webinar. We're gonna represent you the industry overview of sulfuric acid production and operation industry, and there are problem identification, process production challenges, environmental challenges, HSC monitoring and management planning, how to do the management planning, EMP. Then there are 2 case studies included in this webinar. So I'm going to present that how to do the process optimization in sulfuric acid production line, and how to do the mechanical maintenance and process optimization in a sulfuric acid plant. Case study 2 is actually quite difficult task for me because it has to deal with a lot of mechanical maintenance. And after that, I have discussed the conclusions. So how to counter these challenges in sulfuric acid production and operation in industries, with the discussion of HSE and QHSE, as well as the management planning. And at the end, there will be the brief discussion of the maintenance scheme for sulfuric acid production industry. So, dear participants, what are you expecting now? Is there is an industry overview that how we produce the sulfuric acid and what is the process description for sulfuric acid production. Okay, let me just raise the point on this task. So, what is sulfuric acid? As we know, this sulfuric acid is the core chemical of a manufacturing industry, and it is widely manufactured all over the world. Around 200 million tons per year and more than 200 million tons per year of sulfuric acid is consumed in industries. Still, there is a demand and supply gap between sulfuric acid production and consumption in the world. What is the raw material of sulfuric acid production? The raw material for sulfuric acid production is elemental sulfur, which is extracted from the refining process of oil and gas industry, as well as the gas processing industry, as well as the bioprocessing of deamining process of natural gas extraction. There are 3 main sources which I have explained. What is the starting of sulfuric acid process? The sulfur dioxide gas, which is actually obtained by the burning of elemental sulfur in the reactor furnace. So we provide the excess air to the furnace reactor for the complete oxidation of sulfuric acid gases generation. About 8 to 10% of sulfur dioxide gas is produced in the furnace. And what is the process employed for the production? There are 2 types of major process which were employed before the contact process. One was wet process, and second was lead chamber process. But these processes have less efficiency. After which the scientists and engineers worked on the sulfuric acid production in detail, and they have developed the contact processes which are now widely employed around the world. Okay, then there is industry overview. What is the sulfuric industry deals with, what are the kind of application, and in which sector the sulfuric acid is applied in the industry. So from the left side of your slide, you can see that sulfuric acid, that the same thing, that what is the sulfuric acid and why to produce the sulfuric acid, because it is raw material for other allied chemicals which are to be generated. for the sulfate production, for the metal sulfate production, for the paint, for the dyes, for the salt, for the acid, as well as the petroleum processing industries. And one of the key important application of sulfuric acid is the phosphate fertilizers, which are basically the nutrient-rich fertilizers required for the plants and crop production. And around 50% of sulfuric acid is globally consumed for the fertilizer production. Then there come the phosphate generations and the metal processing for the high metal treatment. Then there come the fibers, which are around 5%, and hydrofluoric acid there is generated as a byproduct of sulfuric SOP process, in which the sulfuric acid is a raw material. 2% is used in the paints, pigments, and dye industry, whereas 1% is used in the pulp and paper industries around the world. While there are other some small applications which collaboratively makes 24% of the total application of sulfuric acid in the industry. So there comes the perspective of Pakistan, that how we're going to deal with the Pakistan scenario. The overall production of Pakistan till 2022 August was reported to be 4.169 thousand tons per year, because it is 1,000 tons per year is calculated, as data is collected from the plants and the production lines located which are located around Pakistan in different locations in different industrial states. There is a sulfuric acid trade union. There is a sulfuric acid manufacturing units in Pakistan. There is a sulfuric acid production unit. Sorry, I'm gonna say that there are sulfuric acid production units in different industrial states of Pakistan. So sulfuric acid data is generated and collected by these union and trade unions in Pakistan, which collect the data on regularly basis and to process the data and to provide the government and these other stakeholders for the industry review and industrial development in Pakistan. So what are the major challenges and what are the major changes have been made in the design of sulfuric acid? Because energy is a key factor for the production of the sulfuric acid, and it has been remained a challenge for many sulfuric acid units in Pakistan. So there is a lot of energy recovery mechanisms have been introduced in sulfuric acid generation processes. For example, there are heat recovery steam generation system which generate high pressure steam to recover the heat from the furnace of the reactor, which is generated due to the oxidation of sulfur dioxide gas. Okay, let's begin with the manufacturing process. What is the manufacturing process? How are we gonna start the manufacturing process? First, we have sulfur, then we have sulfur dioxide, and then we are going to produce sulfur dioxide gas, and after that we have oleum and sulfuric acid as our final product. So there are three basic raw materials for sulfuric acid production. One is elemental sulfur, one is oxygen, which we usually take from the air, and then water. Water is used only for the dilution of oleum. It is provided in small quantities to the circulation tank system, so that the acid gravity and density must be maintained at 98.5%, which is actually weight per weight percentage in this case. So what are the processes employed during sulfuric acid production? There are two types of processes. I'm discussing about the type of contact processes which are employed in sulfuric acid production. There is single contact and double contact. So uh, how are we gonna generate sulfuric acid? There are three major steps involved in the sulfuric acid production, which are production of sulfur dioxide gas. Then there is production of sulfur dioxide gas in the catalytic reactor, and after that there is absorption section. And after that absorption section, we have the production of sulfuric acid by the dilution of oleum in circulation tank system. So what are the key reactions involved? There are three major reactions I have noted down in the presentation. First, we have sulfur for burning. We take the elemental sulfur from refinery from our sulfur sources in Pakistan or any country. You're gonna produce sulfuric acid from if you are production. If you are responsible for the production of sulfuric acid, you sort out the suppliers of sulfur in your country. In Pakistan, there are three major suppliers of sulfur. In this case, one is OGDCL Corporation Private Limited, one is Pak Arab Oil Refinery Private Limited, and there comes the other refinery, which is National Refinery Limited, which is located in Pakistan. So we take the elemental sulfur and we melt it with the steam coils. After that, we burn it in the sulfur furnace. How to say? Now there are two stages. There is stage number one is oxidation of sulfur. It takes place as in the furnace at high temperature. It is a lot of heat. Actually, a lot of heat is generated during the process, and we can accumulate that heat to per mole as 300 kilojoules of amount energy is released during the oxidation of sulfur. And after that, the sulfuric acid section comes up with the reactor section. The gas is filtered before entering into the reactor, and sulfur dioxide gas is reacted to form sulfur trioxide gas. It is also an exothermic reaction. And the last one is the absorption of sulfur trioxide gas into water, which forms sulfuric acid. Okay, actually, you have there's a question rises. You have written H2O because H2O is provided to dilute the sulfuric acid. Highly concentrated sulfuric acid is showered in the absorption tower, which generates the oleum, and a dilution water is added to break down the one molecule of oleum into two molecules of sulfuric acid. Process flow diagrams. I'm going to elaborate you two processes. One is single contact, single absorption process, in which let me place you. There is one sulfur furnace. The process starts from sulfur furnace in which sulfur dioxide oxidation takes place. After this, the gas enters into sulfuric acid production reactor, which is we usually call converter. It is a four-stage fixed bed catalytic reactor. Okay. After reactor, the gas passes from the heat recovery system, and after that, the gas is mostly the SO3 gas. SO3 gas is passed into the absorption section, and the oleum is collected from the bottom of the absorption towers. Then the tower is placed under the tower. There is a circulation tank system. Let me just show you with the pointer. There is the absorption. After the absorption section, there are two lines going into the circulation system. The water of dilution is added to generate the sulfuric acid. From there, again a pump is provided, and this pump again showers the sulfuric acid into the absorption tower. So it is a closed loop process. So what is the difference between single contact and double contact process? Okay. In single contact, we usually have one reactor. In double contact, we can have one reactor or two reactor, but there comes another heat exchanger and another heat transfer mechanism involved in the production, and the process loop changes because the gas streams are interchanged between the heat exchangers. Usually in single contact process, there is only one heat exchanger placed in the process. But in the double contact, double absorption process, you can see that there are economizer 1, which is basically heat exchanger 1, and there is economizer 2, which is basically heat exchanger 2. So there is a closed loop of gases, which usually heat exchange take place in between these gases. So at first stage, what is the major difference between single contact and double contact process? At first stage, there are three beds of converter which are separated. The gases first pass through these three beds, not at the four beds. The gases first pass through these three beds, and then the gases interchange their heats between economizer 1 and economizer 2, and the gases from the third bed outlet are transferred into the interpass absorption column. The maximum absorption is done here. The remaining unabsorbed gas is then again transferred into the converter bed 4, and that gas usually goes to pass out from the bed 4 into the final absorption tower. The gas is absorbed there, and finally the stack is released. In both process, there are two major differences. One is in single contact, there are four-stage reactor. In double contact process, there are either 3+2 arrangement. Usually we can say 5-bed reactor or 4-bed reactor with 3+1 arrangement. The 3+1 arrangement implements the strategy that you have first passed the gas from first three beds of the reactor, and then you are going to pass the remaining gas from the last bed or last two beds of the reactor. Then the second difference is the heat exchanger and heat recovery mechanism. In single contact plant, usually they come with one heat exchanger. In double contact, double absorption plant, they come with the two exchanger. Even in the cases, we have to deal with 4 heat exchangers in the process setup if the plant capacity is too large for the production. Okay. Then there is a process, and I'm going to just elaborate you with this pointer that first you have burning of sulfur for the production of sulfur dioxide gas. In the furnace, you provide the dry air, and the sulfur comes from the sulfur pump. Sulfur dioxide gas is generated in this process. It is a highly exothermic reaction. It is a highly exothermic reaction, and about 300 kilojoule per mole of energy is released during this process. After that, the sulfur dioxide gas is to be converted into sulfur trioxide gas. In this process, there is fixed bed catalytic reactor. Pure sulfur is introduced into the furnace for sulfur dioxide production, and we usually keep the composition of sulfuric acid, sulfur dioxide gas as 8%, so that the catalyst can treat the gas coming to the reactor easily. The pressure is kept in between the pressure is kept in between the 1.5 to 2 atmospheric pressure, so that the reactor do not lose pressure throughout the process. And the Lee-Chatelier principle governs the production process in order to perform the complete oxidation and to maintain the equilibrium of the reaction. So there is a key component involved in this sulfuric acid, sulfur dioxide gas production, which is we usually call the catalyst. The catalyst, as you can see on the right side, this picture, this is a pale yellow color star ring shaped catalyst. There are different manufacturers around the world which supply this catalyst. The widely applied catalyst is BASF. After that, we have Shandong chemical company from China, and they come the Hydroxy from Taiwan and Norway. So catalyst is vanadium pentoxide gas, pentoxide, which is a metal pyrometal sulfate component placed on a refractory material. Okay, the overall reaction comes as sulfur dioxide. 1 mole of sulfur dioxide gas react with half mole of oxygen to generate the sulfur dioxide gas, and the reaction usually takes place at 450 degrees Celsius with the pressure kept as 1.5 to 2 atmospheric pressure. And if the plant capacity is large, more than 500 tons, the pressure is usually enhanced more in this case. Then after the last stage, this is the production of sulfuric acid in the absorption section. Okay, the concentrated sulfuric acid from the circulation tank. This tank, I'm going to highlight that this is we usually call the circulation tank. From there, the 98% sulfuric acid available before the production is usually sprinkled in the absorption tower. He just shown one tower just to simplify the process. The sulfuric acid is showered from the top of the tower, and the tower is packed bed absorption column. Random packing is done in order to enhance the maximum absorption, and the pressure and the temperature of the absorption gases and the fluids are usually monitored in this process. The oleum is generated. The oleum is again collected into the circulation tank, where water is added in a minute quantity. The quantity is usually adjusted with the help of a conductivity meter, which controls the whole quantity and the whole requirement of the circulation tank acid, depending upon the gravity of sulfuric acid in this case. So coming to our agenda of discussion, that was the process, and now we have the agenda of discussion. There are two types of sulfuric acid challenges in production. One is environmental challenges, one are the challenges during for the production and operation. So I have listed down some key challenges which we usually face in sulfuric acid production industries. So starting with the process problems, we have three major process problems depending upon the sections. Section wise, we have distributed the plant into three sections. One is process plant starting problem till the reactor. After that, we have reactor section as catalysis, and at the last, we have absorption section. The three pollution types are generated throughout the process, as well as the energy consumption and plant mechanical machinery and equipment challenges are the challenges we usually face in daily production and operation activities. So what are the plant process startup challenges? During plant process startup, we have to maintain the concentration of sulfuric acid in the reactor less than 7%, so that no extra or excess sulfur dioxide gas generated, which can, if generated more than 7 or 8%, it can hardly implement the oxidation reaction in the catalyst. And then we have the plant catalysis and oxidation problem. We have to deal with the catalyst loading, how to distribute the catalyst, how to select the catalyst, and over time the catalyst has been degrading, and the catalyst quality degrades after some time. There are some technical issues we face due by the overheating of the catalyst. Finally, we have in process, there are absorption challenges. Absorption challenges come with the insufficient gas absorption, mostly with the high flow of the gas, or the channeling or weeping in the absorption column, or if the rings are breakdown in the tower, which usually block the tower. And we have even faced the situation of back pressure in this case, because if the back pressure is developed, the plant is going to develop a negative pressure, and overall system gonna fail. Which provide a heavy load on machinery and motors, which can burn in this case. And finally, we have the excess stack challenge. That for most of the cases, if there is a leakage in the boiler or leakage in any water coming side to the plant stack increases. It is a widely followed challenge in Pakistan, unfortunately, because nobody take care of it, and it is due to small cause, which is moisture. If you can't control the moisture during the plant production or plant feeding, there is a stack challenge of moisture which remains throughout the production period. Then we have three pollution challenges. One is air pollution, SOx. Obviously, SOx, if released in more than defined NEQ's level, NEQ's means to say National Emission and Quality Standards. If you are releasing more than NEQ's, then you are going to pollute the air. And many plants are doing this, unfortunately, because of poor control in their process and poor controls and environmental planning. After that, water pollution. If you do not treat the water, if you do not treat the heavy metals from the water, if you do not remove any sources of lead or any sulfur or any iron contaminants from the water, this water will definitely disturb the quality of water in that region. And finally, there is soil pollution, because if the soil dust or any sand dust is generated, or throughout the process the sulfur mud is generated in the sulfuric acid pits. Sulfuric acid pits mean to say where the sulfur is fed and the steam coils are employed, and sulfur is melted with time. The dust on the sulfur accumulates at the bottom of the sulfur melting pits, and it causes the blockage of pit, hence reducing the plant efficiency and causing a depoisoning and descaling, as well as the poisoning of catalysts during the process. And finally, we have two other challenges, which are energy consumption, highly cost of energy production, motors or any fuels which is used during the plant startup. How to economize this? This has been a great issue. Most of the plants have now implemented this strategy of heat recovery steam generation system, which provide them cost saving mechanism for electrical requirement, as they are now producing their electricity from the utility heat recovery. And finally, we have plant machinery and equipment problems, such as if the pumps are not aligned, if the motors are not checked or inspected regularly, or any case of leakages from valves or any controls are not working, then these come the plant machinery problem. And these problems are usually occur during the production phase. And finally, we have electrical and instrumentation. We called it E and I section problem, in which we take the failure of any controller during the production process, or any inverter failure or any motor failure during the production. It directly affects the production as well as the smoothness of the operation. So I'm going to discuss the problems in detail now. As we discussed the problems in the last slide, there is the stack problem, which I'm going to discuss during the sulfuric acid production. I'm going to play the video first. Okay. Now you can assess. There is the stack release, sudden stack release. Can you see the stack release from the chimney?
Yes, we can see the video, and we can also see the release.
Yeah. So again, I'm going to play that video. There's a lot of immense stack release during pump failure. These are the production challenges we usually face in the sulfuric acid production process, and it is totally the SO3 gas, and it is directly the environmental pollution. Unfortunately, it was due to the lack of process control, because no inverter was installed during the production setup. No alternating pump was started in the time. There was no switch gears installed in that switching mechanism, and no interlocking was done, which resulted in quick pump failure and no startup of the emergency pump within the time. And after that, it resulted in immense gas discharge, and you cannot count the quantity. It is about like 3 or 4 tons of sulfur burnt in the air directly, and it has been a major result of environmental pollution. Now, what were the environmental impacts of this sudden discharge to the environment? Okay, first, you can clearly see it is SO3 gas. SO3 has a bad effect of environmental pollution, as it causes the acid rain. Unfortunately, this stack has burned the surrounding crops, and around a region or zone of 2 kilometer radius was completely affected due to this stack. And the people working in that factory were suddenly fell into the asthma disease, and there are many diseases spread for the animals as well. The aquatic life was disturbed, the biotic life was disturbed. The government then took the strong action. Strict action was taken, and heavy fines were imposed for the factory production, and the factory was sealed for further production. This is usually occurred due to the negligence of management, as well as no environmental planning through the management or by the investor or any factory stakeholder, and it is clearly a human error. Then there comes this corrosion due to the acid gas action, because if there is no complete oxidation of sulfur dioxide into sulfur dioxide, the sulfur dioxide gas is highly corrosive in action. It corrodes its own machinery. You can see there are the pipelines damaged in this sulfuric acid production line, The pipelines are strongly damaged. Even the boiler shell is highly damaged. The boiler sheet is damaged, and you can see that it is almost rusted because of the release of these acidic gas throughout the production phase. It is mostly caused due to the leakages on the plant, due to the SOx incomplete absorption in the absorption tower, which causes the SOx discharge from the absorption section. Then there comes the catalysis challenge. So we have the core of the process, the catalyst, which is the most costly process, costly thing in the process, and we have to cater with this challenge throughout the process. First, there is, you can see first graph. Okay, I'm gonna put you to the pointer and gonna elaborate this diagram. This is the fractional conversion bed wise. We usually maintain the temperature at the 450 degrees Celsius. So you can see the conversion is maximum for the first bed, fractional conversion. First bed gives you the maximum conversion, and the extent of reaction is about 75% in this case. After that, there comes the second bed, which gives you the reaction to till 12% more addition. First, you have first bed in this production line, which gives you the 75% of reaction. Then you come up with the second bed of reactor, which provides you about 12 or 13% of the reaction. And finally, there comes the bed number 3 and bed 4 to provide the 100% conversion of the reaction. And now you can see, I'm gonna put my pointer on this catalyst. This catalyst, as you can see, is pale yellow, and slightly alongside this pale yellowish catalyst, there is a slightly bluish catalyst. The pale yellow catalyst is in 100% good quality, but the bluish catalyst is not in the good quality because it has lost its valency to +5 to +4. It has lost its strength with the time due to the action of moisture as well as the catalyst poisoning or fouling generated during the process. So what are the challenges? First, we face the catalyst deactivation. As the sulfuric acid process is totally dependent on the temperature control of the process, we are going to face the catalyst deactivation if excess temperature is provided to the start of the catalyst. Usually it occurs at first bed. The high quantity of catalyst is degraded if feeding gas temperature is more than 500 degrees Celsius, and the catalyst becomes totally null and void for this production process. Then there is catalyst replacement challenge. You cannot replace the catalyst without any calculation. You have to provide the calculation for all of the catalyst which has been destroyed through last production phase, and it is usually done during the shutdown process. After that, you have catalyst selection. Either you're going to select the good quality catalyst of Germans or European manufacturers, or you are going to start your production with the Chinese or Taiwanese production. We usually in Pakistan prefer the German BASF catalyst, which because it has provided its good service life for more than 7 years, which is a really good image of this catalyst. And after that, it has a good mechanical durability and strength. And finally, it can withstand with high temperature more than 500 degrees Celsius. Even if you feed more than 500 degrees Celsius temperature, due to some process malfunction, it can still survive at that temperature and will give you the reaction for sulfur dioxide gas oxidation into sulfur dioxide gas. Finally, the catalyst storage. You cannot store the catalyst in an open area. You must put that catalyst into a packed space in the drums or either in the fully plastic covered sheets. And finally, you have to prevent it from the moisture, because if you add it in moisture, the catalyst immediately is discarded as it absorbs the moisture quite effectively from the surrounding environment. And mostly the shutdown activities are hence carried out during the summer process in summer season in Pakistan, because during the summer season there is a high temperature of the surrounding, less moisture is available in the ambient air, so less chances of catalyst moisture effect affection is expected. So finally, how to solve these challenges? Those were the challenges, and how to counter these challenges. First, we are going to deal with environmental challenges. Air pollution is the major source of pollution, and usually generated by sulfuric acid production lines. So the sulfur dioxide gas is usually converted into sulfur dioxide gas in the single contact process in one reactor, but the double contact reactor provides us 2 times sulfur dioxide gas into oxidation into sulfur dioxide gas. We can do their
the oxidation of sulfur dioxide gas into two stages. First, by sulfur dioxide gas in reactor SO2 to SO3 in reactor 1, and finally SO2 remaining SO2 into SO3 in the reactor 2. So it provides a conversion efficiency of more than 99.9%, which ensures the process safety as well as the quality of the process, and hence prevent us from the discharge of any kind of sulfur dioxide into the environment. Finally, how to treat the sulfur dioxide? We employed the wet scrubbing process. We provide the caustic soda and highly basic solution for that. And after that, we have two instrumentation mechanism in our production line. One is SOx detector in the production hall. Either is there any kind of leakage or any mechanical pipeline leakage in the plant, so SOx detector will detect it and will bring out an alarm for this case, so that the mechanical team can work over it. And finally, the SOx detector are placed or at the stack to ensure the safety emission limits are followed throughout the production phase. If there is the more discharge than the national emission quality and control standard, more than any cues, then the production process is checked throughout from the start to the ending of the process, and it is tried to ensure to minimize any sort of causes which are causing the SOx emission in the environment. Then there come the water pollution. We usually employ highly basic solution of caustic soda, which is I've just mentioned you. And finally, the effluent water treatment. Water treatment plant is placed employed in the plant to ensure the process plant waste is treated throughout the process. We have usually waste generated from the caustic soda treatment, which is we are calling the wet scrubbing process. And this wet scrubbing residue is treated again to take out the solution of sodium sulfate, because as a reaction, sodium sulfate is generated, and usually about 5 to 10% concentration of sodium sulfate solution is generated, and this solution is again sold out in the market, while the other water discharge from the plant is treated into the wastewater treatment plant, and final discharge is done in the environment. But this water is not recommended for any kind of commercial or industrial or any agriculture use. And then there is a noise cancellation or by soundproofing. We usually do the soundproofing by placing some plastic and thermophores structures around our blower motors or high intensity motors. And then there comes the health hazard from the acid storage tanks. We usually keep one acid storage tank empty throughout our production period, because if there is a leakage from any storage tank, the level of the storage tank is quite about 20 or 30 feet, and it contains about tons of our product, which is directly the uh, our value product, as well as, and it has harmful effect for the nature. So we have to prevent our cost as well as the environment. So one storage tank is kept throughout empty throughout the process. If there is any leakage, the sulfuric acid is transferred from one tank to another tank, and the quick mechanical maintenance is done for this that affected storage tank, and in order to provide the safe and smooth shifting of acid. And finally, dike wall means any it is dike wall basically is boundary type structure. We usually construct a wall around acid storage tank so that no unauthorized personnel from the plant or other than the plant is allowed to enter in the storage area. Only the storage area field operators are allowed to enter in the storage tank section, and they inspect the storage tank section on regular basis, on hourly basis, and provide the report to shift operator or shift engineer, which ensure the process safety. And finally, to protect the human and the workers working in that industrial section, the acid proof uniform, acid resistance personal protective equipment, including helmet, safety goggles, safety masks, safety dress, safety shoes, is provided for all the workers, regardless of the status of the worker. Either he is from engineer or a manager, he must have to follow the safety implementation rules which are defined there, and safety policy of the company must be uh, implemented by the management on site to ensure any kind of process hurdle, as well as to eliminate the risk from the process production and operation phases. Finally, how we do wet scrubbing. So a wet scrubber is usually a mechanism. There is a tank behind. It is basically a packed bed column type structure. We usually make a caustic soda solution which has pH more than 14, and to ensure the complete neutralization, the continuous feeding of caustic soda is done in the new water to make up the new solution, and that solution is showered again and again on the tail gas which are left before this stack. We treat the gases entering before the stack by this wet scrubbing process to ensure any kind of no minimal amount of SOx is released throughout the air. This caustic soda or sodium hydroxide solution is is a safety parameter for us, because we we shower continuously the sulfuric caustic soda solution on our acidic tail gases, and it generates the sodium sulfate solution in this process. Now there are the reaction, because first you can see the sodium hydroxide and sulfur dioxide gas react to form sodium sulfide solution, which generates along with a water molecule generated. Then there's the thing, there is sulfur dioxide gas generated with the oxygen to provide the sodium sulfate solution. Both sodium sulfite or bisulfite or sodium sulfate are generated in this process, and we extract these solution in the form of 5 to 10%, and finally this product is also sold out to our soda and napsa manufacturing industries. Then comes the environmental management planning. How we gonna implement our environmental management planning? How to ensure the environment risks are completely eliminated throughout the production phase? We develop an environmental management plan, and it covers following aspect. It usually deals with the environmental management to control the water pollution, to control the air pollution, to control the noise pollution, to control the stack problem, to control the challenges during the production phase, to control the leakages from the process. And finally, we have the water usage management and disposal. We have to treat our water, we have to take our water from the natural resources, and we have to ensure the economization of water, that we are not using water than the government defined quantities in our the process, for the either for cooling or either for utility purpose or either for our process purpose. And finally the disposal, we have to treat our water, our wastewater generated from the plant before its disposal into the water. Then there is recycling and waste management. The waste generated during the sulfuric acid production is sulfur mud or sulfur dust. These sulfur dust and sulfur mud are again mixed with the sulfur which is to be fed into the plant, and this sulfur mud is collected at the end of a shutdown, and the sulfur mud is collected and sold out to the research labs, which usually are now conducting research on the application of sulfur for our soil. And finally the pollution prevention. All the stakeholders, all of the stakeholders working in the all of these stakeholders working in the sulfuric acid production line are responsible of pollution prevention and environmental management. And finally the transportation is important in this concern, because you have to follow the safety protocols throughout your transportation of product. Raw material sulfur is not that quite immense effective for the human health or any kind of pollution, but our product sulfuric acid is highly corrosive liquid, and you cannot touch it with a bare hand. So you have to ensure the transportation safety throughout your production phase. And the goods or the transportation trucks which are carrying our product are ensured to have to be followed all the safety protocols. You usually provide the drivers with a safety kits and a chemical symbolic representation, as well as the hazard symbol are placed on our trucks before any kind of selling of sulfuric acid into the market, so that all of the vehicles on the road must see clearly the danger symbol from our trucks, so that they remains at a distance. Because if you are effect of any transportation leakage or any tanker leakage from of sulfuric acid, the sulfuric acid will directly splash on the floor, and it will directly burn all of the people which are passing through it. What are the recommendations? So environmental management plan, you have to define the environmental management plan. You have to all of the plant stakeholder, including the management, the technical and the process staff, as well as the mechanical staff, are the key stakeholders in this process, and they have to ensure the process safety. So how to implement this environmental plan, and how to cater these environmental as well as the production challenges? We usually recommend our 5 to 6 priorities, and I have listed down them. First, we must provide our environmental impact study and with the recommendations to our management. Environmental management plan must be followed on site, and there should be a complete plantation around the scope of the project. It means then there should be a complete plantation, and trees must be grown around the plant, so that to ensure the discharge of dust or any kind of gases within the plant are not released more outer than the environment. of the project site. Then water treatment plant, wastewater treatment plant is established in 2 units. 2 units are installed on site. I usually recommend 2 units because first unit cannot treat the water completely into neutral water pH. The second has the side two water wastewater treatment plant, 2 stages water treatment plant has shown quite good results in this case, and it has ensured the water quality can be used for agriculture purposes as well. Wet scrubbing system. Most of the production facilities in Pakistan lately have emitted the scrubber from their mechanical structure, which was a quite concern for me as well. And now, whenever any site I visit, I usually first note down the scrubber, because if there is no scrubber, there will be direct environmental discharge or environmental emission released from the plant site. So, wet scrubbing must be carried out throughout the process. You cannot omit the wet scrubbing, or you cannot show any kind of compromise because of the cost of the caustic soda chemical. That cost of caustic soda chemical is in turn the process safety for your own plant. So you must have to provide the continuous waste gas wet scrubbing mechanism. And finally, natural resources which are used in the production should be economized, must be placed in order of required quantity. Cannot Do not use the natural resources in the excess quantity. And we should not waste any kind of natural resources which we take in our production line. So in order to implement the environmental management planning, there are five type of major responsibilities or five major concerns. One is institutional arrangements. Your management, your general manager, your production manager, your mechanical manager, all of the stakeholders in this case, and they have to train their staff for the reports and documentation. Complete reporting and documentation must be carried out throughout the production and operation phase, as well as for the shutdown task and the job description. And finally, the environmental and social training. HSC training must be conducted on sites for all of the staff, including the laborers, including the workers, for the general staff, for the administration, for all the people working at that site. Environmental trainings as well as the social training. Finally, mitigation and monitoring plan. Mitigation plan refers to our document which we have provided to plants for the mitigation of all pollution challenges which we face throughout our production phase. And the monitoring. The general manager, the administration manager, as well as the factory stakeholders are obliged to follow the planning which we have provided for our clients, to ensure the environmental management plan is working smoothly and regularly monitored by and inspected by third party. Third party inspection can provide good results in this case. Okay, there are that was the brief discussion of the process challenges which we usually face during the production phase and the operation phase. Now, case study one, Fazal Chemicals Private Limited. It was my first job of sulfuric acid, and we have faced those challenges in our production line. So we have just elaborated some process parameters that the plant was single contact, the double single absorption and double contact process. We transformed it that. After that, we have raw material elemental sulfur, and the plant capacity was 100 ton per day, but it was unfortunately reduced to 75 ton per day because of undermined production due to many causes which have I listed in this right section. Finally, there comes the boiler and the converter section and heat exchanger. I've put it down all the description of that plant. What were the problems which we identified for our less production? The plant capacity was 110 metric ton per day, but we were obtaining about 75% on average production. So it was due to the catalyst side issue, catalyst challenge. And then there are the damaged pipelines with leakages and sulfate in piping and tubes of heat exchangers. There was a heavy sulfates were deposited due to the sulfuric acid gases metal action to form the metal sulfide. Ferrous sulfide was generated in this case. Poor gas processing. Poor gas processing means that the gases passing through each stage was not converted into the desired product. For example, if I can say that in the sulfur burning, there was a less feed concentration, less than 8 or 11%. Okay. Finally, we have less conversion of sulfur dioxide gas into the sulfur dioxide gas. It was again the cause of sulfur SOx emission. And after that, it was totally due to the catalyst quality. Three major concerns we faced during this process. One was catalyst quantity. For this 110 metric ton production of acid, we usually deal with 100 drums of catalyst on an average. It is generally is just a rough estimate. but we found around 60 drums were placed in that plant, unfortunately. Then we have to face the catalyst poisoning. After some time, the catalyst was poisoned, and the catalyst was deactivated because of the high temperature operation. And finally, the poor absorption efficiency, the towers were choked, the rings were broken down, and no acid was distributed throughout the absorption tower, which caused a stack increase for the process. So there is a process flow diagram. Okay, this is for your reference. I've just put it down with the mentioning of all equipment which are involved in this production line. So major components include the sulfur furnace, the waste heat boiler, the catalytic reactor. After that, we have heat exchanger. Finally, we have two absorption tower and one dry tower, and there is an acid cooler, circulation tank system, and finally there is storage tank system. I will share you data, yeah, after this presentation. So as you can see, there are these are the observations which we noted down during our process plant shutdown. Okay, in left right, you can see first the red pointer shows the sulfate. Heavy sulfate were deposited in the heat exchanger of the shell and tube heat exchanger of the plant. You can see that the picture was taken at the night time, and the gray slurry type liquid slurry type solid is found on this tube on the shell header. You can see that tubes are broken down and tubes are highly ruptured. Let me mention that place. The pointer is passing through a tube, but the tube has been cut down with time due to the sulfate formation. Then on the catalyst, you can see that catalyst color has been changed. There is a dust and catalyst poison action has been observed on this catalyst surface. You can see the catalyst, as you can see from the catalyst picture in this slide, the catalyst has been suffered from the catalyst poisoning action due to the fouling and the dust which has reached, unfortunately, passing through the filter of the plant. So it was also a challenge. And finally, at right hand, you can see the tubes of the heat exchanger, which are usually the stainless steel tubes and are highly resistive to the corrosion action, but unfortunately they have been corroded and formed the sulfate in this case as well. Okay, how we did the process optimization. You have seen all of the causes from this process, but now you're gonna see the process optimization. We did it directly from transforming conversion efficiency, enhance the process, and the results are better in case of double contact, double absorption plant. Finally, for ensuring the feeding section, we enhance the plant feeding sulfur ratio by a replacement of air line, race-based replacement of air line for the sulfuric acid, and excess air supply was provided in order to ensure access for the complete oxidation. And then we have placed the concentration analyzer, which is basically an instrumentation equipment for the ensuring of a plant process to ensure the conductivity of acid at 98.5% of the acid in this absorption tower, and it optimized the capacity of the acid. And finally, we increase the volume of the catalyst for the required process, because the volume of the catalyst at that site was less than the required. They have been operating the plant with 60 drums of catalyst for a 100-ton plant. It was an immense mistake, and it was like kind of a human error made by all of the plant management because of lack of knowledge and lack of experience in this regard. So they placed the catalyst, and I provided them quotation demand for the catalyst requirement, and we enhanced the catalyst quantity in our plant, and we use the cesium doped catalyst. It is basically a catalyst which have 7 to 8% of cesium action deposited on the layer of catalyst, which enhances the oxidation process for sulfur dioxide into sulfur dioxide conversion. Finally, we have defined the complete bed distribution and catalyst loading for our sulfuric acid reactor beds, and these reactor beds distribution provided us the good results in this concern, and we have achieved the conversion efficiency of sulfur dioxide gas into trioxide gas. It from first three beds as 96 to 98.5%, as I can just place from that pointer. So, and finally, as you can see that on the next slide, left to right, a new reactor was designed during this process. A new reactor was designed for the process description. The left to right, first two pictures are of the reactor, and second one, the last one, which I'm placing on the right side, is basically a heat exchanger. These reactors were designed for the process optimization, and new reactors were installed in the process, as well as an additional heat exchanger for our process transformation was also installed in this process optimization case. And there are some pictorial grips of units placement, that how we place that air line. As we place that complete air line for excess air supply, the first line dia was less than required less than required diameter, and hence that was resulting in reduction of air supply and airflow of the gases. So we increase the line dia after designing and calculation, and we replace that air line as well. And we have implemented complete DCS control structure policy, and I'm going to show you that SO3 SO2 production line. You can see that it is a complete human interface built by DCS system, and any operator to directly see the parameters of gases passing through the reactor to on this computer screen and control the process and to ensure the process smoothness. The engineers and the operators are obliged to ensure the process safety throughout the production process, and now plant is operating on double contact double absorption plant. So in this complete whole, you can see the whole causes are noted down in this and provided in this list. And after that, you can see that how we implemented the process optimization and how we did the process optimization goals. Now, then there is there is our case study too. That is Pakistan. It is located in Multan. Okay, how we did the process optimization? First, we have uh, we have the plant structure. You can see plant structure on the right hand. It is highly corroded due to the negligence of operator, as well as no proper shutting down SOPs are followed during the shutdown of that plant. Unfortunately, this plant has been banned due to the license cancellation because of environmental discharge from the you can say from the process plant. The plant released that gas, and the video I was showing you just before that was another industry. But unfortunately, the problem that occurred during for this plant was also the same. It has also released that stack from the process plant, and it caused the ban and the cancellation of license of production for this industry as well. These industry uh, came to me for consultancy, and I am still in process for these clients. So what are the causes of this process? Full production process control. No educated operator were kept on this site by the management, and they have no experience of process control. No controllers or any type of mechanical or electrical inverters or switch gears or synchronizer were installed on this site, and lack of maintenance. They have no schedule of maintenance for the plant. How to conduct the maintenance activities? How to make that schedule for maintenance of plant, and how to avoid any kind of non-scheduling activity for this plant. And finally, there was catalyst poisoning. The catalyst was highly damaged in this plant. In this case, as well, the plant was shut down without any notice by the government. And the operators just left the plant at that stage. Unfortunately, no acid line or no gas line was cleared, and the plant was just shut down by just switching on that button, which causes a bad effect on the plant structure, and it has damaged that plant into complete rusted plant. Now, it has poor environmental management and the high corrosion activities involved in this plant. So you can see the process flow diagram for this plant. In this plant has some mix up of single contact and double contact type scheme. So we have just first and we have a heat exchanger involved between first and second pass of our reactor. But although the other structure remains the same, and there is no bypass line between the boiler and the backward filter in this case, and there are air EQC is installed instead of heat exchanger, and there is a blow. So the whole structure is single contact, but the absorption section is double. So we call it this plant as single contact double absorption plant. Okay. So this was the unit, and I will provide you the presentation material, and you can clearly view this diagram by yourself. The equipment are listed down, as well as the consultant, as well as all of the description is noted down in this diagram. So now coming back to the point, no line was clean, no acid line was clean during the shutdown. No acid was collected in the circulation tank. The acid was remained in this line, and you can clearly see. I can show you by the pointer that this line is made up of cast iron, which is a highly corrosion resistant iron in this case. But unfortunately, with the passage of time, the rusting action has uh, completely completely eaten up the whole elbow of the pipe. You can clearly see. and that there comes the there comes the tube header section of heat exchanger, and you can see the complete sulfate formation on the top of this region. The yellow structure you can see is completely the sulfate formed due to the result of high corrosive action, as well as some of the highly corroded section is on the below, which I'm now pointing you. And finally, you can see the acid quenching coolers. These coolers must be made empty before any type of process shutdown or any mechanical activity. But unfortunately, the people doing the job there were not realistic about that. So they did not realize the importance of this section, and they left this section, and the line has been completely damaged from this section. You can see that there is a complete pipe eaten up between this, and there is a lot of scaling and rusting on this acid cooler. So it has to be completely changed. And there are many more on this site. This site I visited last month in Multan, and there are many more problems on this side instead of corrosion and any kind of catalyst. So what were the recommendations I made for them? You can clearly see this plant is single contact and double absorption plant, but to run it for the better environmental compliance, you have to you have to do the complete revampation of product. You have to invest more for your plant equipment, for your plant pipelines, for your process smoothness. You have to implement complete process shutdown of about 4 to 6 months, so that all the maintenance activities, which I'm gonna list as preventive maintenance and preventive shutdown in this case, to be done for this acid plant. And finally, uh, throughout the process, only the reactor external structure was good as compared to the other plant equipment. I am talking about just mechanical structure, because in the oxidation reactor, the catalytic reactor, there is no kind of acid contact, so the reactor was not damaged in this case. And finally, what were the causes? The shutdown management was not followed, and any kind of SOPs were not found on the site, which result in the non-clearing of the project. Clearing refers to a term which we usually say in the sulfuric acid sector, as we have to take out all of our raw material, we have to consume all our raw material before any production shutdown, or we have to take out all the acid before any shutdown. But unfortunately, on that side, the people responsible had not taken that steps, and they did not clear the plant during the shutdown, and it resulted in the loss of millions in Pakistani rupees, and it is an immense damage to our economy as well as the livelihood of workers for doing job there. And finally, the plant shutdown should be conducted for preventive maintenance and double contact. I refer to all of the manufacturer now, because double contact double absorption process has yielded good results for environmental compliance, as well as the smooth operation and maintenance of procedure of the plant are obliged throughout the double contact double absorption process. There are less production challenges in double contact double absorption process. There are better process controls in this double contact double absorption process. So then we are coming with the plant HSE analysis and risk assessment, and how to ensure the HSE compliance for our production plants. As in mostly sulfuric acid is just not that large scale industry, unfortunately. But in Pakistan, you can see that there are two case studies I have highlighted on my presentation, and you've clearly seen that management action and staff action are completely responsible for all of the process troubles in this case. So how are we going to do the process analysis and risk assessment for our plants? First, we have listed down the hazard and what are the effects, what are the challenges, and how to do these challenges, and who will be responsible for this challenge. And finally, what is the time to take out that action? For example, we have gas pipeline leakages. It can either come from the plant production phase, plant startup phase. So who during this plant pipeline leakages, the plant staff or the environment are damaged, because the gas is discharged into the environment. So people working in that area can breathe that dangerous gas, and it can result for their issues for their lungs and causing asthma. And how to cater this challenge? We have to do our maintenance, and plant mechanical staff is made sure to is obliged to make sure the leakage maintenance. And finally, we have to do it before any plant startup or any on-site during production. On notice during production mean that any leakages, if it occurs during the production phase, we usually take a break of around 10 to 30 minutes for that leakage maintenance, and we call it small notice shutdown activity. And then there are acid leakages challenge. Who can be affected? Plant staff that are working, either if any acid is splashed or fell on the skin of any human working in that area, or land or water are effective. We have to do the maintenance. The plant mechanical staff is applied to do the maintenance. It can either occur during the plant startup. We have to do it do it in our preventive maintenance phase, and finally or in notice phase if any leakage occur during the production phase, as I mentioned you in the challenges section. Then there is absorption acid pipeline leakages. If any leakage occur during the production phase, the plant staff and the soil workers can also damage. And if we same mechanism, we have to take the preventive and on-site maintenance activities, and plant staff is obliged to ensure the plant mechanical team is obliged to ensure the plant leakages maintenance, and it can either be included on the plant preventive maintenance period phase, or if it occurs in during the production area phase or production period phase, we have to clear the plant by taking 30 to 30 minutes to 1 hour 1 hour time shut down our production during our production activity, and then we restart our process. And finally there are stack control and emission control challenges which are occurred during by the negligence of plant staff and environment, and unfortunately they themselves are also being threatened by this challenge as well, because plant staff has to take the responsibility to ensure the plant stack and control emission control. And the plant stack is directly as you've seen in the video that sulfur dioxide gas is falling on the surroundings near the plant, so that plant staff is first to be affected from that sulfur dioxide gas. And then there is the environmental whole of the environment and ecosystem around that 2 kilometer or 3 kilometer radius was affected in this case. No automated plant control was installed during that site. So how we're going to do this? We have to eliminate this by automatic plant controllers, and production staff and production management plant management must be obliged to ensure the process safety. And finally we have to tackle with pump and water failure. In this case, we the plant equipment and plant process is disturbed, as well as the environment. You have seen in this last video that the pump got failed suddenly, and the time it took some time to switch on to the emergency part. But meanwhile, around duration of 1 minute, about like 3 or 4 ton of sulfur which was burned during this our production process was released into the air, and it was completely sulfur dioxide and sulfur dioxide gas, unfortunately, and that caused immense damage for environment as well as the community of that region. And finally, we how to eliminate that risk? We have to install automated plant controller, protective equipment, and on-site maintenance by the product plant production maintenance and mechanical staff. And we have to do it either by installing our mechanical and electrical system before plant startup and plant shutdown, or during the plant notice period activity, in which like if we have any trouble in pump replacement, we shut down the plant for about 1 to 2 hours, and the whole activity is conducted and supervised by an engineer to ensure and eliminate any kind of risk for the environment as well as the plant personnel. So next is mechanical compliance and operation and maintenance. Maintenance is the key concern for process smoothness. Process safety is directly related and reliant on the maintenance level achieved by the plant production staff. So how are the maintenance tasks to be done, and what are the jobs to be done throughout the production phase? So there comes the six key section of the sulfuric acid production line. First, we have pipelines repairing and maintenance. Then we have boiler repairing and maintenance. Third, we have reactor and absorption towers section. At last, we have circulation and air cooling to air quenching coils. AQC stands for air quenching coils and heat exchangers. So how are we going to do this? We divide the plant into six sections, and after that, we just start from repairing our pipelines. We start by repairing by pipelines, all of the pipelines which are acid circulation pipelines or gases pipeline or any pipeline during our production in our process. We do it by welding or by fabricating or line replacement. If any line is a lot of damaged or affected by the corrosion, we totally replace that complete part by a new part of line. And then we after that we are encountered with a boiler. Here come the tube replacement, shell replacement, and third party inspection of boiler. So first we ensure the tube replacement if any tubes are damaged, and then we ensure this shell replacement if any shell is to be replaced. Third party inspection services are taken in order to ensure the boiler safety and to check the pressure limit. So how are we going to do that job? By doing the non-destructive testing at high pressure. It means that we have to test the pressure of boiler about more than 1.66 time of the desired operating pressure, because let's say if we are operating, we're desired to achieve the steam or generation of about 250 psi. We must test that pressure, that boiler at 400 psi, to ensure that if any process fluctuation, the boiler can withstand the extra pressure limit. Then we do it by fabrication and by ensuring the safety valves. Then there come the reactor. We do it by reactor fitting and welding. If any leakages or any catalyst loading is disturbed, and we directly do the instrumentation. And then there comes the absorption. We check the rings, the acid distributors, and the acid showering pipelines. That if anything is not affected, then we're gonna if anything is affected, we're gonna do that by ring inspection. Or if any rings are less than the desired, or rings are broken down, we install new rings in this tower. And distributors are newly installed and checked on a regularly basis during the shutdown activity. And you can just conclude that all of the mechanical tasks are to be done during the shutdown phase. The shutdown activity is limited to more than 4 to 6 months for sulfuric acid production line, and we have to provide a complete shutdown of plant by uh, by by making the production of plant after by making the production of plant into 4 to 6 months. We usually take the production of plant up to 6 months, 180 days, and after 180 days, it is recommended to put that plant onto a complete shutdown. And after that, again, preventive maintenance is done before plant startup. Finally, the AQC and heat exchanger. Because the heat exchanger employed, there are shell and tube type of heat exchangers. So the tubes are checked and inspected regularly to ensure the ASTM strength of the tubes and to ensure the AQC loops are in good condition. If any tube is damaged, tubes are replaced by new tubes, which are usually the SS type seamless tubes. Seamless tubes mean that which are non-welded in the structure as per ASTM standard. Usually we apply the ASTM 3164C standard. 3146C standard is implemented for the tubes in this case. And finally, the welding and leakages of AQC loops is done, so that uh, in order to ensure all kind of the plant leakages, all kind of plant troubles of mechanical structure are completely rusticated and eliminated in the shutdown phase. So a brief shutdown is taken. The whole production phase is put down onto the rest phase, and the mechanical staff come into the action. They provide the shutdown services for the maintenance of plant, and plant is maintained completely after a complete production phase and for the preparation of new production phase in a specific period of time. So that was the complete whole discussion of our today. And how we're going to conclude this, as you have completely seen the, the complete webinar, that with the case studies as well, that the plant challenges include mostly the mechanical, the QHSE, the environmental compliance, as well as the industrial regulation compliance. So how we're gonna implement that? We have to implement the safety policies in our plant. We have to ensure the QHSE standards are completely followed in our plant, and the environmental impacts are are taken as less from the plant. Because if you are emitting more than national NEQs, national emission quality control standards, the plant gonna affect the whole industry surrounding, as well as the community living near the plant site, and the government will fine you heavily. After that, there are second researcher going in nowadays, investing in more in research and development for the new process development. And finally, addresses the challenges, you have to deal with the new scientific development and research, as well as the catalyst research for the smooth production of sulfuric acid. And finally, it is important for sulfuric acid industries to use environment and effective safety compliance management strategies to ensure the safe and sustainable use of catalysts. I have provided you a complete overview of sulfuric acid industries and the challenges. So it's time for your questions. If any of your questions, please let me know so I can answer your questions. Hello? Any questions?
Thank you so very much, Saud. Thank you. Thank you for the great presentation. Just like you said, does anyone has any questions for Saud?
Please ask me down your question, if you have any question, so that I can answer your question. Hello?
I think people don't have any questions. I think you were very good in explaining your presentation, Saud.
Okay.
But
Okay, no, it's no problem. So
but if anyone
thank you
has
for your
any
time and
questions,
your attention. And if anyone have question, I'm still on there.
Nope, I guess there are no questions. But goes without saying, once again, thank you so very much, South, for the wonderful
Yeah, yeah.
presentation and for sharing your industrial insights. And if anyone has any questions afterwards, feel free to reach out to South anytime on LinkedIn. And like he mentioned in the very beginning as well, that he's also the founder of his own consultancy firm. So remember to reach out to him and connect with him so you can learn more about him. And if you have any questions or so, then he will be more than happy to answer. How can people get in touch with you, South? Can you briefly
Yeah,
tell us
people
on
can
that?
just reach out me on my LinkedIn account. I have mentioned in my profile as well, and people can reach out me using my LinkedIn account, my email address, or they can even contact me on my provided phone number, either from international clients or from national clients as well. I'm now working with national and international clients on my LinkedIn account. So you can reach me by using your LinkedIn account and directly just put a DM in my LinkedIn account, and you can provide your you can ask your queries in and you can ask your queries to me in your email. I provided my email address on the top of the presentation. If you allow me, I'm just gonna take you back on that slide. Like if anyone is interested to reach me, just follow us
I
on
have a
our
question.
yeah. Yeah, there is a
How do
question.
you measure the thickness? How do you measure the thickness of piping? I mean, like, do you use corrosion coupons for the corroded amount of the pipe, or how do you measure that?
Yeah,
In,
during the shutdown activity, we measured the affected corrosion layer by taking out the pipe after during our shutdown, and we take a good sample of that pipe that was placed in that heat exchanger. We compared that, and the layer deposited, or the layer which was eaten up, the layer of sulfate deposited was calculated as by the sulfate was taken out by just mechanical etching of the rubbing of the pipe, and the sulfate was taken out, and after that we seen the complete thickness reduction of the sulfate eaten pipe. So we compared it with with a good pipe, good quality pipe, which is placed in this tube, as well as the pipe which has eaten up by sulfate. We measured it by thickness of mechanical QC inspection, and mechanical staff that provided measured that by using the mechanical equipment such as screw gauges and all of mechanical stuff. So pipe thickness is usually now if I further highlight to that, the pipe thickness we take for our small pipes is around 8 to 10 mm, which I'm discussing about heat exchanger, you know. And if there is economizer type pipe, we usually take the thickness as 6 mm for our pipes, which are SS pipe seamless and ASTM standard 31446C. And if there is the pipeline, the major pipeline, there are the different type of thickness we take during our installation phase. For example, if there are acid pipelines, acid line, I'm talking about the acid line on the absorption section. The thickness, their thickness is around 16 mm. And if we are talking about the large scale pipeline, the air pipeline, the gas flow pipeline, which is really in diameter of around 2 feet, or in 1.8 1 feet and 8 inches, mean to say 20 inches, then there the thickness is around 15 mm. So there are different sizing of piping, and depending upon the application as well as the strength of the pipe for our process. Yeah, any
Thank
Thank
you
you,
very
question?
South.
much.
Does anyone else have any questions they'd like to ask right now? No. Then once again, thank you, South. And just like how South said, so if you guys have any question later on, or you would like to connect with him, then do remember to connect with him on LinkedIn and drop him a message. Uh, at the same time, if you have not done so already, then do remember to visit www.ChemEnggLife.com and become a free member today, so that you can join in on in our other initiatives as well, and maybe join in for our future webinars. And also don't forget to visit our YouTube channel and subscribe to that. And of course, if you are a job seeker right now and you would like help in your CV making or whatnot, then we also have done a little bit of partnership with jobmink.com. So do visit there as well, and you can get help in CV making and applying for jobs both in Pakistan and in abroad. So do remember to visit both these websites. And it goes without saying, thank you so very much to all of you for joining in, for making time to listen to the webinar. And also, huge thank you to Saud for being with us here today and for willing to share your industrial knowledge. We are truly grateful, and we now hope that you all have a great day and a lovely weekend ahead. Thank you.